We have learned that the planets revolve around the Sun. We have assumed Sun as the center of the circular path of the planets. Actually, science says something else. Astronomer Johannes Kepler was the first to observe that the path of the Mars is not circular. From his observations, he could show that the distance traveled by the planet near the Sun is more than the distance traveled by the planet when it is away. From this, he could show that Mars revolved in not a circular path but in elliptical orbit. Before going to the orbit of the planets, we first learn what is an ellipse. To learn about ellipse, let us recall what is a circle. If a locus moves at a constant distance from a point, then it is called as a circle. Circle has all the radii equal. The case of ellipse, it's quite different. The locus moves at a distance from two points known as the focuses or foci. The sum of the distance from each point to the perimeter is always constant. We have an ellipse here where there are two foci. At one we have Sun, and now we take the orbit of planet. This is Mercury. Look at the distance of Mercury to Sun. It is less than 1 astronomical unit, the distance between Sun and Earth. Whereas the eccentricity, that is the stretch note of an ellipse, varies as elliptical nature increases. When eccentricity is 0, in case of Venus, we can say it is not elliptical. In case of Earth also, the Sun is almost at the center. That is why we don't feel any difference between whether the Sun is away or near the Earth. But the same is not in the case of Mercury. In Mercury, the planet sometimes is near and sometimes it is away from the Sun. From these observations, Kepler could predict that the planets are not revolving around the Sun in circular orbits. Instead, they are moving in elliptical orbits.